Hope everyone had a great conference. I hope to end it on a good note for you. So we're going to talk about consolidating DNS data in the cloud with Amazon Route 53. I'm Lee Zen. I'm a dev manager for the service, part of Edge Services. Great, so let's jump right in. We're going to talk about why you should do this initially and why it's the right time. So it really comes down to a lot of the same things about moving into the cloud. Cost. Cost is a big reason to consolidate your DNS in the cloud. Running your own DNS servers can be expensive. You have to operate them, and you have to run lots of them. When you use Route 53, we operate dozens of edge locations around the world, and we charge by the query. And so you only pay for what you use. You're not going to have to pay a whole lot. We're talking about 40 cents for every million queries. Simplicity. You can manage all your stuff in Route 53. Consolidating everything makes life a whole lot easier. You have a single view of all of your DNS. You can have all your hosted zones in Route 53. You can manage all your DNS data in one place. And you can manage it all via our easy-to-use API. Hopefully, most of the people in this room already know most of this, so I'm going to keep going pretty quickly. Today, we'll be covering basic DNS use cases, so really how to migrate the more simple stuff and how to consolidate all of that within Route 53. And then we're actually going to talk a lot about advanced use cases with private DNS and some of the cool things you can do in combining your existing architectures with private DNS. So the diagram we're really going to be looking at is something like this, where you may have example.com, whatever domain or set of domains you currently own. You may run a public DNS server, and that public DNS server may be serving your DNS on behalf of your domains out to the general internet. You might have some third-party monitoring. You might have some things looking at whether your servers are healthy or not, checking to see if latencies are good, whether or not things are actually running. In your own data centers, you might have your own system monitoring as well, plus maybe even some more internal DNS servers to serve DNS within your corporate network, for example. We're going to talk about moving all of that into the cloud. And so we'll be doing that with Route 53 public zones, Route 53 health checks, and Route 53 private zones. So where do we start? Well, we can start by bulk transferring all of the domains that you currently manage into Route 53. And that might seem like a pretty daunting task, so we're going to do it step by step. The first step is to export DNS into Route 53. What this means is taking the DNS that you currently manage and having the way that those records are served and actually having Route 53 serve them on your behalf. The next step is to actually delegate authority to Route 53. And what that means is by delegating authority, when other resolvers on the internet are attempting to do DNS resolution, they will contact Route 53 instead of the existing DNS servers that you use. And the last step is to transfer domains to Route 53. So in case you didn't know, Route 53 actually offers domain name registration. You can go and buy or transfer domains into Route 53. So you can go to Route 53 and you can search for mynewdomain.com and buy it, or you can transfer an existing domain into Route 53. And here we're going to talk about bulk transferring all your domains into Route 53. And actually, you'll notice that the order here really matters. It really matters for availability. So you could do it the other way. You could first transfer the domains and then export and delegate the authority to Route 53. We don't recommend doing that. The reason for doing this in this order is this guarantees that you first have Route 53 serving your records before you actually transfer. In some cases, if you transfer first, the transferring registrar may decide to, if you, for example, have your DNS coupled with your registration, you may actually lose DNS resolution as part of the transfer process if you transfer first, depending on the registrar you're using. So some registrars actually, when you transfer domain out, decide to stop serving the DNS records on your behalf once you do that. So we highly recommend going in this order by making sure that your DNS records are being served by Route 53 first before you transfer the domains over. So how do we export the DNS? This is highly dependent on your existing DNS provider. We'll talk through two examples. First one is if you use someone like GoDaddy for your DNS. GoDaddy, if you go to their website and you log into your management console, there's actually a DNS zone file tab. And there's an export option, you will select that, and that actually download the zone file. And then you would download a zone file for each of the zones or each of the domains that you want to transfer. Or if you're running your own bind server, for example, typically you would find this in wherever you have your named configuration. So if you're using like a Cheroot jail or something like that, you might find it in var named, and you would have your zone files hosted in there. You then use CLI 53. It's an open source command line script tool to import the zone into Route 53. So here's a pretty easy example. You can see we really just iterate through each zone file. And you can really just, with 2 commands, create the zone and then import that zone file into Route 53. And so what this will do is it will create a hosted zone in Route 53 and then shove all of the records from that zone file into that hosted zone. And then now that zone is ready to serve the records on your behalf. At that point, you'll want to delegate the authority to Route 53. So this is the step I mentioned where now name servers, or resolvers rather, on the internet will be able to contact Route 53 in order to do domain name resolution for you. So this step is registrar dependent. Here's an example. If you use Namecheap, for example, as your registrar, they have an API. You would be able to go to the API, provide your API details, and then you would issue this command to set the DNS servers to the delegation set. So you can see here we have 4 name servers listed, NS425, NS793, et cetera. Those name servers come with each hosted zone. So when you create a hosted zone in Route 53, you get a unique set of name servers. And so you would do this for each of the domains you were transferring. Again, you could imagine how you could easily script something like this. You'll want to check that you're actually delegated. So simple example would be to do a dig trace. So we have an example up here showing how you can, this is a concatenated output, so you can see, remove some of the less interesting details. But first we have the roots name servers, followed by the .com name servers, and then finally followed by the name servers for AWS architectureblog.com. And you can see that for those name servers, those are actually delegated to Route 53's name servers. After you've done that, you'll want to wait for the TTLs, the time to live, on those records to expire. So here you can see that the time to live is 172,800 seconds, which is 2 days. And so we'll want to wait for those 2 days before we continue doing anything else. So after those 2 days, all the resolvers around the world should hopefully have, by that point, expired their caches and now see that Route 53 is authoritative for this domain. And at that point, we can transfer the domains. Again, depending on who your domain name registrar is, this is going to be dependent on the registrar. You'll want to unlock the domain so that it can be transferred. Here's another Namecheap API example. And then you'll want to obtain the authorization codes for those domains. So for example, GoDaddy actually has a bulk download option. You would go into the console. You can get all your domain codes, the authorization codes in bulk. And then again, we can script this. I have a Ruby example up here using the AWS SDK. You would use the AWS SDK with the Route 53 domains client. And here you can see we go through each of the auth codes for each of the domains. You can imagine having this auth code CSV, which might have your domain names and the actual authorization codes. And then here I've actually not shown the full arguments, as what you will need to do is you will actually include the domain name plus the authorization code plus all of your contact information per typical domain transfer configuration. So that takes care of the public zones. That's pretty simple. So now you can imagine if we've done something along the lines of what I've just outlined, we'll have transferred all of the authority to Route 53. Route 53 will be serving all of our public DNS records, for example.com, and we'll have transferred all of the domain name registration into Route 53 as a service. What about the monitoring part, though? So let's talk briefly about that. So you can take advantage of AWS integration once you've actually done this transfer. One of the cool things you can take advantage of is alias. Alias is a specific record type within Route 53 that allows you to point your domain name apex at an Elastic load balancer or CloudFront distribution or S3 website. And so in a very simple way, you can actually point the apex, which you normally would have to CNAME, which you can't do. But taking advantage of alias, you can actually do that and point that at those resources. You can also take advantage of Route 53's health checks and DNS failover. Recently, in case you didn't know, last month we launched calculated health checks. Calculated health checks allow you to combine multiple health checks into a single health check using and or rules. And you can actually also manually failover health checks using calculated health checks as well. So it's a very powerful tool both for DNS failover. So in my previous talk last year, I talked a lot about how you can take advantage of Route 53 DNS failover to do all sorts of conditional flows and things like that, basically treating alias trees as a way of having a decision tree, essentially, or a logic tree within Route 53 record sets. I encourage you to check out that talk from last year if you didn't catch it. So you can use DNS failover to really have really powerful ways to decide how to dynamically return different answers based on the condition of your system. And calculated health checks adds a whole new dimension to being able to do that. In addition, it really helps provide a replacement for any kind of monitoring solutions you might have in place today. So in addition to calculated health checks, we also announced latency measurements as part of health checks last month as well. And so when you create a health check, you can also get back latency measurements against whatever endpoint you're checking. And so those two things combined can really help you with all of the monitoring for an endpoint. So now we've gotten the third-party external monitoring moved over. I should have mentioned also that Route 53 actually checks your endpoint from multiple locations around the globe. And we've also been able to move the internal system monitoring over, since we actually are able to monitor your instances within the EC2 as well. So now let's talk about this last piece, moving internal DNS over. That's actually pretty simple too. We can set up private DNS. So what private DNS is it's a way to create a private zone within your virtual private cloud. So within your VPC, you can actually have a hosted zone that is only visible within that VPC. This was a feature we announced last November. And so you can see here I have a simple console example that shows creating a domain name, example.integ, and associating it with a specific VPC ID. So from within that VPC, example.integ is now resolvable, but only from within that VPC. You can actually associate multiple VPCs to a zone and multiple zones to a VPC. And again, if we wanted to script this and make this really easy, we can simply use Cli53 to import all our zone data from our existing internal DNS systems into Route 53 private DNS. All right, so we're done, right? We moved everything into Route 53 and into the cloud. We have our public zone being managed in Route 53. We've managed to move all of our monitoring solutions into the cloud. And we also have even our private DNS data in the cloud as well. But not quite. It's very possible. In fact, lots of customers we talk to have laptops or clients sitting in their corporate networks, or they still have various reasons to keep an on-premise data center around. So what do we do about that? So let's talk about how you can actually take advantage of private DNS in conjunction with an existing data center. So in order to do that, we have to talk a little bit about what it means to use the resolver within the VPC. So within the VPC, typically, the resolver is going to sit at what we call the gateway +2 address. So for example, if your VPC subnet is a 10/16, then the 10.0.0.2 address is going to be where all your DNS resolution happens by default. The way private DNS works is you query that 10.0.0.2 address, again, in the 10/16 example, and private DNS combines both the resolver and the authority into one. So this is kind of a limitation where it means you can't use the 10.0.0.2 address as an authoritative server. So some customers have wanted to, for example, delegate to 10.0.0.2. That doesn't quite work because it actually acts as a resolver, not as an authoritative name server. Similarly, the 10.0.0.2 address is actually not addressable from outside of the VPC. It's kind of a magic address. And so we'll talk about various ways in which you can work around that. And finally, delegation back to other name servers via NS records within private DNS doesn't work either, again, because of the fact that we've combined the resolver and authority in the way private DNS works. So these are some limitations of the way private DNS works within VPC today. We're definitely aware of these limitations and are working toward making them better. But fear not, there are actually really cool things you can do to make everything work. So we're going to talk about that. So here I have a diagram showing kind of an on-premise network. Again, could be an existing data center or your corporate network. We have a query. We have a resolver that the query is going to go to. And then we would like that query to be able to go through to Route 53 private DNS in order to get some kind of answer. So for example, you might imagine you might be running something in VPC that you want to be able to address, and you want to be able to actually get the answer for that. It could be some kind of internal application server or whatever it is, but you need to be able to get to that address. So what you want to have happen is you want this query for that name to go to the resolver, and from that resolver to go to the +2 resolver sitting in the VPC, and for that to actually ask Route 53's authority, OK, well, what's the answer to this name? And for that query answer to travel all the way back to the original client who wanted to know. But as I mentioned, that doesn't work because the path from the resolver to the +2 isn't going to exactly fly. How do we fix this? We can stick a forwarder in between. And this actually makes everything work. So we can actually have the query go to the resolver, which goes to the forwarder sitting in your VPC. This DNS forwarder will then forward the query on to the +2 address, which is now visible since the forwarder is sitting within the VPC. And then the query will then go on to query the private zone, and then the answer will flow back. We'll talk about how to set up this forwarder now. So a super easy way to get this forwarder set up is to just run Unbound as the forwarder. So you can imagine spinning up an EC2 instance, installing Unbound, and then configuring Unbound. And so here we have a sample Unbound configuration. This sample configuration essentially tells Unbound to listen on everything and answer all queries from the local subnet. We reload the Unbound configuration, and voila, you have a forwarder in your VPC that is able to allow your on-premises network to be able to query Route 53 private DNS answers. Oh yeah, one last configuration. You have to actually add the forward zone. So here we actually have name as the root, and this forwards this is setting it up to forward all of the queries to the +2 address that I mentioned earlier. You can also imagine changing the name here from the root to some other domain. So for example, if you only want to forward certain queries to the +2 address, you could do that as well. Another option is actually to set up AWS Directory Service as the forwarder. And this is actually the recommended method because it's A, fully managed on your behalf, and B, if you want to utilize Active Directory within your virtual private cloud, you actually get to take advantage of that as well. And this is actually really easy to do. So if you've never played with AWS Directory Service, you can go into the console, and if you pop open the AWS Directory Service part of the console, there's a button that says Create Simple AD. And so we will create a simple Active Directory within our VPC. Typically, the way this gets configured is you'll be asked to have 2 subnets within your VPC. Those subnets are where the Active Directory controllers will be placed. And so here you can see we have 2 DNS addresses for our directory in this example, the 10.0.1.114 and 10.0.2.135. And if we hop onto a host within that VPC, you'd see something like this for the resolve.conf. So for people who aren't as familiar, resolve.conf specifies how a host is going to do its DNS resolution. And so here you can actually see that the name servers it's pointing to are those 2 name servers that were configured as part of creating our symbol directory. So just to show a quick example, this is a example of a private hosted zone in Route 53 called cloud.zen. And we have an example record here, example.cloud.zen. It's a text record. It says hello world. And so if we go to the instance running in that VPC and we were to dig for example.cloud.zen, we would actually get back that answer. And you can see, if you take note of the server replying on our behalf, it's actually the Active Directory server. So it's the 10.01.114 address, which is the Active Directory name server that's actually answering on behalf. So the way we recommend customers configure this is so you have Active Directory running within your VPC. And we actually suggest managing all non-Active Directory names in private DNS. So when you run Active Directory, you actually get a DNS server as part of Active Directory as well, and you can manage a lot of DNS within Active Directory. However, we recommend managing all of the non-host names, everything that's not part of your Active Directory installation in private DNS for two reasons. One, it's going to fall through. So for example, if the name isn't in Active Directory, it's going to continue to go to Route 53. So what you can then do is use the API endpoint in Route 53 as opposed to having to figure out how to script against Active Directory within your VPC and having a less accessible endpoint. The other reason is zones can cross regions with private DNS. So as I mentioned earlier, you can actually have a single zone associated with multiple VPCs. Those VPCs don't even need to be in the same region. And so this allows you to have a single view across all your availability zones, all your regions, all your VPCs, and manage it all in one place. Whereas if you were to do this in Active Directory, that would be a regional view specific to that VPC where the Active Directory lives. So going back to the diagram, we have something that looks like this, right? We have a query going to a resolver, going to the forwarder, to the +2, and then the answer coming all the way back through. And so far, we've configured this forwarder orange box. How do we configure the box that's the resolver to make sure that it talks to the forwarder? That is also very easy. I'll show two examples, one for bind and one for unbound. So assuming you run bind or unbound in your corporate data center or in your office or wherever it is, for bind, you would simply have those two forwarders set up, and that's the first example on the top of the slide. So there, you would have all the queries from your on-premise data center go through and hit those two name servers that are in the VPC. So this is assuming, by the way, that your VPC and your on-premise or corporate data center, or whatever it is VPN together and possibly direct connected. The second example on the bottom half of the slide shows an example where you have a single zone that you're going to forward. So here, maybe you only want to forward queries for that specific zone into the VPC to get resolved. Similarly, you can do the same thing with unbound. The top half of the slide is also if you wanted to forward everything through, and the bottom half of the slide is if you only wanted to forward that one single zone. Another thing I mentioned earlier is that it's not really possible to subdelegate a zone, or it's not possible to have NS records within your private zone that end up being respected. And this is, as I mentioned, due to the fact that we have the resolver and the authority combined. So kind of that right-hand side of the diagram, those really are one unit in the way that it looks within the VPC. And so what we recommend here is to flatten your zone instead of subdelegating. What this means is if you have a subdomain, say sub.cloud.zen in this example, instead of creating another private hosted zone called sub.cloud.zen, simply manage all of those subdomains as part of the existing zone instead of creating additional zones. And so this is a simple technique to ensure that everything gets resolved cleanly and easily. Another use case that customers often run into is that the on-premises resolver or DNS infrastructure contains data that's not in private DNS. There's actually multiple ways to deal with this. One way would be to loop the query through the on-premises system. Another way would be to copy the data into private DNS And a third way, which we won't really cover today, is to set up conditional forwarding in Active Directory. This last method is assuming you're running your own Active Directory server and you have the ability to actually set up conditional forwarding. So we'll talk about the first two. So this is going to be a little convoluted looking, but this first slide we're going to talk about, this is kind of what it would look like from, this is the existing view. So this is if the query is coming from on-premise. This all works. And here, what if the data is actually on the other side? So you have a query originating within the VPC, but the data is sitting in the on-premise network. How do we get that data back? And so we're going to do something a little bit roundabout by looping the query through the on-premise. So actually what we would do is have the query go back into the on-premise infrastructure instead of asking the local DNS, and then having that continue through to the forwarder, to the +2, and to Route 53. So here, in this case, if the local resolver already has the answer, it's just going to answer and return back to the query. If not, it's going to continue forwarding through and forward into the VPC, and just as before, clicker is not working. Just as before, the query will come back through. So in the first case that I mentioned here, if the query is originating from within the VPC and the data is in the on-premise network, by routing it kind of back through, we would be able to ensure that anything that's already in the on-premise network will get answered, and if it's not, it's going to continue all the way through. The way you would configure this is to, as we talked about in the resolve.conf, have the hosts actually search the name server for the on-premise resolver first before it searches the forwarders within the VPC. The other option would be to copy the data into private DNS. And so pretty easy way to do this is to use a tool called Route 53D, or you could use Clyde 53. So we talked about Clyde 53 as an import mechanism earlier. Route 53D, if you go online, it's an open source tool that allows you to essentially transfer zones into Route 53. And I have a sample configuration here. Out of Route 53D, it's fairly simple. You would essentially specify the domain name that you care about and the corresponding zone ID in Route 53. Run the Route 53 daemon on your DNS servers, and that will keep the data synced between your DNS server and Route 53. And so by doing this, you'll actually just simply have the data sitting in the Route 53 authority, and you can have the query go directly to the +2 resolver from your client, query the authority, and have the data come right back. And here, you would get back the answer for whatever on-premise data that you actually cared about. Right, I actually zipped through this pretty quickly. So in summary, consolidating your DNS infrastructure in the cloud is easy, and it simplifies management of that infrastructure. You're able to manage both your private data and public data all in one place. There are a number of ways to combine private DNS with an on-premise or existing solution. We talked through how you might be able to copy data back and forth, or how you might be able to route queries throughout the data center architectures. And we're aware of some of the limitations around the +2 address and are actively working toward making that situation a whole lot better. Please complete your evaluations if you have a chance. Thanks for your time. I hope everyone had a great reInvent. And if you have